Well, good afternoon. I'm Ted Willke with Intel, and I'm from the Data Center Software Division. I want to talk to you today about how to make friends with graph analytics and graphs. I was grateful for Mark's introduction. If you caught the last talk, I don't have to explain what a social network graph is. So it may surprise some of you that Intel's even into software, but we have over 10,000 employees working on software. We work on recently working on HPC, big data, and cloud computing. And the division that I work in has a keen interest in building the building blocks, the tools that can go under end-to-end solutions for large-scale analytics that involve graph processing, machine learning, and data mining. And of course, so the question today is, can I make graphs your new bestie? And we're talking, of course, about rich models like the one on the right there. This is an example of a multi-property graph. There are nodes. There are different types of things, people, places, things, other more abstract things, related by edges of different types, and they can have multiple labels on those things, and we can use them in analysis that I'm going to go into. So my challenge is to see if I can help you friend graph analytics, and by that I mean, if you're going to reach out and friend someone these days, you're probably going to do it using a social network, or at least connect at some point using one. And so I'd just like to offer a couple pieces of advice. Really important not to get a rejected friend request. It can be quite humiliating. So one thing to keep in mind is know who you're dealing with before you send one, and whether you're convinced that you share common interests. In terms of the graph problem, I mean, I'm kidding around a little bit here, but in terms of the graph problem, I'm talking about really understanding if whether a graph and graph analytics can solve your problem, because it's a big area. It's getting hyped up a lot, along with a bunch of things in big data analytics. It's not for everyone and everything. So there's no way I'm going to close this issue for you today, but I'm going to show you some examples and give you some guideposts to help you deal with that question by example. So here's a graph that we did with a large service provider customer. It represents, the nodes represent channels, and the edges are channel switches. So we're looking at the surfing behavior of people as they watch TV. And by looking at the most treaded paths, we can help the service provider better target their advertising dollars, and also make predictions about where someone's going to switch that may be very non-obvious. But with that, we can advertise on one channel for something that's happening on another. Here's another one that we did with our wholly owned security subsidiary, McAfee. So we built a giant graph with them. This particular one is not the one I'm talking about. We have a graph with them that's now 4 billion nodes and 10 billion edges that represents a security problem. So basically, we're talking here about an IP and domain reputation inference problem. By having some ground truth labels on a very small portion of those entities, and by looking at their associations, we can use guilt by association and a technique in machine learning called loopy belief propagation to label many more, and many more than we have ever been able to do with McAfee. So on the left are the priors, and on the right is the labeling with the risk level. And with this type of thing, maybe you can target security policies more intelligently. Here's one we did with Intel Media before they were actually, you might have noticed that we sold off a group to Verizon recently that was building a set-top box. We were doing analytics behind that to make content recommendations. So one interesting way graphs can be used is actually to examine low-cost paths. So if you want to understand the amount of interest that someone may have in a subject matter or something like a movie, you can find these minimum cost paths in the graph that relate the person to their interest through various dimensions like the cast that they would be interested in, how similar it is to other casts and topics, and so on, and make very accurate personalized recommendations with the graph. Well, that's just a few examples. But I think more important than providing more and more examples would be to give you some guideposts. So you can do this exercise on your own, figure out if graphs are for you and your problem. Well, one Mark just demonstrated, social networks. If you have a problem that is inherently a network problem, an information network problem. You've obviously, graphs are great for you, and graph analytics that you would run on those graphs to analyze them is perfect. Less obviously, so there's a lot of algorithms out there in machine learning and data mining that use graph techniques. One example would be Bayesian inference networks. So you're propagating probabilities that relate to one another. You can express that problem with highly factored functions, but computationally that's often not very efficient. Graphs are a better form for the computation itself. You can also study relationships, like the Intel Media example. So whenever you're looking at finding a golden path within a data set, this is a perfect tool for you. And then finally, more abstractly, you can think of a bunch of matrix computation, classic matrix problems in machine learning and data mining that have a lot of zeros. And a graphical representation is just a better way of putting the emphasis on the non-zero values in those structures. And you can do a lot of the same math with them. And on the right is some examples of other ways we use graphs. And Mark also talked this kind of a social network-oriented view of it. So I encourage you to think about these areas when you're considering engaging with graph analytics and getting to know it better and spend your time on it. Consider these guideposts for you. Okay, so once you've actually friended graph analytics and gone through that stage, what's worse than not having a rejected friend request is getting unfriended, or wanting to unfriend someone you friended and they're sending you all kinds of things in their timeline. It's driving you nuts and all that. So some advice on this too. If you want to keep the friends, socialize them with your other friends. I mean, make common connections and make sure you can build a sustainable relationship, that you have the energy to put into the relationship that you establish. And do that before you go into it. So in terms of graph analytics and tools, what I mean by this is combine the new graph analytics technology with existing tools, with proven tools and the ecosystems that are healthy already. So we've got Apache, we've got the Hadoop effort there and non-Hadoop efforts there, and that's great to build on. And then relate to the technology through UIs, like Mark had mentioned, showing a bunch of visualization UIs. There are other types of programming UIs. Use one that you're familiar with. Don't get dragged to all these new, the efficiency programming languages that we use under the hood. It's not necessary. These tools are coming along really fast. It'll come to you. So go look for those good projects. All right, so I want to go a little bit into how we address that unfriending issue. So here's one sustainable way. The vision is a combined platform. Let's bring the graph analytics pipeline. So when I refer to graph processing and graph analytics, what I mean by that specifically is the ability to construct large-scale graphs and then store and analyze them so we can label them with new information like we did with belief propagation and the security network, and to serve those models. So we want to use them with other machine tiers, and people want to run queries on them, data analysts and data scientists. We need architectures to do that whole gamut and plug APIs in for, we can plug in visualization tools and other types of analysis on these things. And we can build that all on top of file systems and NoSQL stores and management services that we have today, and not reinvent all that stuff. That'll help the IT department with the problem as well. We also have to look at the problem and step back from the systems perspective and look at the data science workflow. What are the pain points? I'm sure that you've observed these pain points. They're classic. Some of them are emergent because of the big data problem. But at the conference, numerous talks about the pain of data ingestion and wrangling. There are the workflows that are underlying the big data systems weren't designed with iterative workflows in mind. Maybe they do some iterative computation. I'm talking about the workflow level problem. Feature engineering to building a model to going back, it's not right, do the engineering over, and so on. Not good. Skills shortage at the intersection of cluster computing, distributed systems work, and data science. Obviously, it's going to, if you're an employer, that's a real problem, maybe good for us in the room. And if you do have those skills and you're going to set off to do this, it's still a lot of do-it-yourself, glue this stuff together, find the UIs, plug everything in, and see if it works. Spend millions of dollars on that if you're going to do it commercially. And hopefully, if you bring graph into it, you can start mining relationships. So, yeah, the challenges are huge. And so we went out and validated these challenges we'd heard people screaming about with our customers and our partners, and we decided to build something. And this is kind of a super high-level view of what we're doing. And I'm going to get into a couple of these things in a second. First of all, it's key to have ease of use. I mean, performance was where graph analytics started, like how fast can we speed up a MapReduce job and so on, how fast can the computation go, but now it's ease of use is really the barrier to adoption. So we need a productivity interface on top of the entire pipeline. We need to provide the data wrangling and graph construction tools. We have a project called Graph Builder that's great for that. It brings a graph-based approach to that ingestion problem. And then we need to be able to feed that into scalable databases that scale with the rest of the pipe. There are very few of those out there. One example is the great open source project Titan. It's built for graph problems. We'll look at it in a second. And then we need to be able to throw that information up in filtered ways into graph engines, analyze it, annotate things back in the database, and then serve that information out to services. And hopefully leverage the management service and the underlying Hadoop and other components that we already have. And so our customers validated the investments in these areas, and that's what Intel's doing. And we're going to open source this stuff and democratize the technology. In other words, make it as low cost and supported as possible. And in fact, to this end, in December, we released a news release announcing a few of the components that are related to this problem solution. Intel Graph Builder, a 2.0 version. I'll go into that in a second. Also, an upgrade of our security and manageability features of our Hadoop distribution. Yeah, Intel ships an Intel Hadoop distribution, and it's by and large all open source. And then I think a very exciting part of this related to the data science problem is the Intel Analytics Toolkit, which I'll show you what's in that. But it's a really nice spectrum of algorithms, both graph and non-graph. It's cool. So it's starting to come together, and there's going to be a lot more this year. So just briefly on Graph Builder, you can go get that now. It's completely open source. The previous one, you had to write Java, you had to understand MapReduce and all that. You can now write this using data flow scripts in the Pig Latin language and the Pig framework. You can bring your features in from raw sources like XML, extract objects, build them into a graph, store them into a graph database quite easily, scoop them right into something like Titan. It's a great tool. The Analytics Toolkit is also great. It's got a lot, and we're just expanding it like crazy. So it's an interesting spectrum. You can see that we've got everything from things that would be useful for social network analysis. So this is the machine learning part that we were talking with Mark about. So this is the way you would do it, bringing that technology. We've got structured prediction, collaborative filters, and all that. And a lot of these on this list, all the way down to classic things that we've been doing for years in machine learning. The top of the list are things you'd think of doing with a graph approach. These are algorithms that would be good for with a graph approach. The bottom of the list, not so much. The things in the middle, there are some things that you could go either way with. We decided to draw a line. In this new system, those top algorithms that I have there are all implemented using graphical approaches and execute on graph engines and would have outputs, result objects that would go into a graph database and so on. But the beauty of it is you don't have to worry about that if you don't care to. The toolkit's there, you get the whole spectrum, and you don't have to use different tools or UIs to work with the graph and the non-graphical algorithms. So we believe that type of combined analytics platform, along with a really nice UI, leads to easy insight. And to make the point about the UI part, there's nothing better than a demonstration. So I'm going to invite one of our bright young engineers, Zach Young, up here, who's going to give you a live demo from Portland, Oregon. Demos we like to do them live. This is not a canned thing, so I get a little bit nervous every time, but you've got it together, right?
Yeah.
All right. So we're going to run one and do a fairly simple but interesting analysis of co-occurrence trends. So in the actually, leave it up for a second, will you? In the over time, co-occurrence has been used to look at trends over time. So if you or Walmart, and you have a loss leader product, you're going to lose money on it. You want to see if people are going to come in and they're going to buy something you're going to make money on. So you can look at co-purchasing patterns with co-occurrence analysis. We're going to analyze the Medline database. Just about any medical paper written goes into it, 24 million papers. And we're going to look at co-occurrence of keywords in there, which can lead us to new discoveries about and innovations in medicine. So, Zach, take it away. I think actually, briefly, again, I did it to you again. We're just going to look, sorry about that, we're going to look at that pipeline. So we're going to go, this is an indent problem. We're going to extract from XML, right from the Medline database. We're going to build some features out of it and filter them. And with that standard ontology of features, we're going to build a co-occurrence graph that we can then mine. So let's do it.
Okay.
Now I can switch you back since I slammed you.
That's all right.
There you go.
Well, anyway, this is an example record, and the goal here was to pull out those keywords that are at the bottom here and build a graph out of it, and then look at the relationship between those terms. We end up getting a structure that's similar to this. Like in the upper part of this, we have stem cells and Parkinson's, and so in 2012 there were 10 publications that had those two terms in them. So that's the kind of relationship that we're looking for. So I'm going to switch over to a Python notebook, and we're going to start with the beginning of that pipeline. So we're going through the ETL that we wrote to do this. So this is all that high-level Python, and under the hood there's all this MapReduce, Pig, Java, HBase. All of those technologies are utilized underneath. So here we're reading that XML, but we're given an HBase table that just has a list of XML blobs. And so there isn't a lot of structure to them. And then so these next steps, we extract the information from that XML. So these are all Pig scripts underneath, but you don't have to worry about that. We supply that kind of functionality. So this ETL reads through some other databases, joins it in, but basically we're given all the vertex information at that point. So this is sort of that data construction loop that Ted was mentioning earlier. At the end of this, we have to get the relationship information. So there's this self join that gets the pairs of terms that we're looking for. So when we're done with all of this, we end up with the edge list that can go into the graph. And so all of these steps are some kind of cluster level functionality going on. But let's do something a little more live. That can take about half an hour or so. Anyway, so here we build the graph. This is using Graph Builder 2.0. This function runs Graph Builder, and all we're doing here is telling Graph Builder what in that HBase table is the features of the graph. So we're pulling out those IDs to turn them into vertices, and then from there, Graph Builder turns the rest of that table into edges and applies those properties. So we end up with a property graph that's distributed on the cluster using a Titan database. So what I started here was the building of that graph. It won't finish now, but
it'll take a few minutes, right?
Yeah, it'll take a couple minutes.
So we're going to play like what is it, Julia Child's?
Yeah.
Okay,
So
this turkey is ready in the other oven, so we're going to go get it.
So, but this is, I left in the call that's just showing what's going on underneath. This is what's actually happening on the cluster, is this big call to kick off a big MapReduce job. So regardless, once we have that database, now we can use it to do things. This is just a simple lookup. We can call this and we can get the records back. Pretty straightforward.
So what is that you're using to look it up? What kind of syntax are you using?
Well, this is Python, and we're using a library called bulbs that translates that into a graph query. I have a little more advanced example. Once you get through that, the natural next question is, I want to see all the edges between these two. So here we run this query, which is using Gremlin, a graph query language, and that allows us to actually perform the query.
Gremlin's supported by most of the graph databases out there. It's the predominant one.
Yeah.
So it's worth learning so you can traverse graphs quite easily for queries. It's like SQL for graphs.
Yeah. So at the end, we run this query. It's all in Python, and our result is a Python object. Makes it very easy to work with. At the end of this, we use this to drive a visualization. So we ended up with this chart. It's running the exact same query under the hood, and we get this time series. As you can see, we have a data quality issue, so that means we have to circle back.
That little
dip.
So this is the co-occurrence analysis?
Yes. So the bars are the co-occurrences, and the lines are the raw counts of those terms individually. And so we were able to find this problem and circle back and adjust for it much quicker because we had this tool set to go end to end.
Yeah. So let me wrap up. So thanks a lot, Zach. Yeah, I mean, that's the point. You can't really avoid the iterations, but if you can get to the insight faster, it doesn't matter. You're going to get through more iterations faster and be more productive. So I just want to say that you're going to get help with your new friends this year if you go for graph and graph analytics from Intel. We're going to put out a combined platform for graph and non-graph machine learning and data mining. It's scalable to commercial applications. That is our objective, working with partners, and we're doing it. And hopefully you can see that Python, R, and other languages can be brought to the cluster so you don't have to learn a lot about Apache Hadoop and that ecosystem to do your data science work. And, of course, we'll open source our efforts. So thanks for your attention. Please come see more at our booth. There's a great booth talk by our Director of Data Science, Kathleen Crow, tomorrow on this topic. And stop by and interact with the technology. We've got some live stuff up for you to try out, and visit intel.com graph. Thank you.